this assessment, we're asked to design a synthesis of the molecule shown, specifically using a carboxylic acid and an organolithium reagent. Now, organolithiums react with carboxylic acids to make ketones, so it's good that we're being asked to make this molecule, which is a ketone. I'm going to go ahead and number the carbons, or number the atoms, number the groups. We'll call the phenyl group just number 1, carbon 2, carbon 3, carbon 4, 5, 6, and on. We maybe didn't need to number all the way to 11, but let's do it. The reason we point that out is because there's 2 bonds that we can make doing this reaction or doing this process, 2 different syntheses. And one would be to make the 3,4 bond, and so we'll do that. The other would be to make the 4,5 bond, and so we'll look at how we might do that. In each case, what's going to change is which side is the organolithium and which side is the carboxylic acid. So let's start by making the 5,4 bond. Each of these reactions is going to finish with an acid quench, so we can go ahead and write that here, that we'll do an acid quench as the second step of the process. And now, since we're making the 5,4 bond, 4 having the carbonyl is very likely going to, or will have, the carboxylic acid functional group, so we can basically draw carbon 4 and then decorate with the rest of the molecule. If we wanted to number it, again, it would be 4, 3, 2, and 1. And this carboxylic acid should then react with the rest of the molecule as the organolithium. Now recall, because organolithiums are strong bases, we're going to need 2 equivalents, one to deprotonate the carboxylic acid, and the second to do the nucleophilic attack. So the organolithium reagent we might use for this reaction will be this one, and we'll use 2 equivalents. This will react with this carboxylic acid. Let's number our carbons. Carbon 5 is nucleophilic, carbon 4 is electrophilic, and so we would end up with this as our product. Numbering the carbons makes sure that we haven't made a mistake outside of understanding the chemistry. So we want to make sure that our understanding of the chemistry results in a correct answer. Numbering carbons helps with that. Now, what's the other way we can do it? Essentially, we're going to flip. Instead of having carbon 4 through 1 be the carboxylic acid, we're going to have carbon 4 through 11 be the carboxylic acid. And so the molecule, the carboxylic acid we draw here would be this one. Decorate the molecule, number the carbons, gives us that. Step 1 then would be to react. We're trying to make the 3,4 bond. So carbon 3, carbon 2, and the phenyl group. We'll put the lithium on carbon 3. Going to need 2 equivalents for the same reason. As a strong nucleophile, it will first deprotonate. It will act as a base to deprotonate the carboxylic acid. The second will add as a nucleophile. And then the last step is the acid quench, which converts that dialkoxide into a diol, which then collapses to give the ketone. These are the 2 ways we can synthesize the ketone on screen using an organolithium and a carboxylic acid.